Hi everyone. Hi students. Good evening. Let me spotlight myself. Okay, all can see me. Okay, now welcome. Today's session will be going through the O-level pure chemistry paper. Okay, there's quite a number of you. Any one of you in combined science? Just want to check. Is anyone of you in combined science? Gabriel, hi. Welcome. Why are you here? No, just kidding. Now, we are going through pure chemistry paper actually. So of course, if I don't know whether you have the paper. Yeah. Do you have the paper, Gabriel? Okay, but anyway, we are going through the 2021 paper for pure chemistry. Okay, if you don't have the paper, then mind, it's okay. Then just look at the screen. So for the rest, please take out your own TYS. I believe all of you have at least one copy of TYS. Okay, by now you cannot find in the popular bookstore anymore. Okay, so we are going through the 2021. And I believe many of you will have attempted the question because at this point of time, if you have not attempted the question, then we don't have a lot of time. So make sure you try all the 10 years of papers. Okay, let me uh, um, okay. Screen. Oh, you have your paper already? Now we'll be going through the questions. And if let's say and I go through, you have any question, you just let me know. Now, why we choose this paper? Because I think section B, there are some interesting questions which we wanted to highlight. Okay, so that's why I choose this paper. Of course, we could have chosen 2024 last year paper, last year paper. But I believe your schools will have gone through with you. Am I correct? Did your schools go through with you the last few years paper? Just put in the chats. I don't think your school teacher has all the time to go through all 10 years. So let me know which year your school had went through, just to let me know. Guys. Okay. Thanks, Gabriel. Oh, that's 5 years, right? Yeah, 5 years of paper. Okay. That's quite a lot actually to go through 5 years of paper. What about the rest? No? Your school never go through paper? Hello? Anyone else around? Or are you all not ready yet? Oh, your school went through most of it. Yes, hi. Yes, thank you, Aris. Welcome again. I think it's the same one, right? Same Aris. Yeah, and Robertson, thank you. Hi. Yeah. So my question is, how many years of paper did your school went through? I'm talking about the school going through the questions, huh? Oh, your school never go through Aris. Not at all. They go through prelim papers, maybe? No? Yes. Robertson, what about you? And the rest? Okay, go through prelim paper only. All right. I mean, that's normal. Okay, but I was expecting some of the teachers to go through uh TYS questions, but pretty sure some of the prelim papers have some of the O-level questions, okay? Because they are all questions that your school teacher predicts that might be coming out. Okay, so it's good to have attempted a lot of prelim papers. Okay, but if you have not, you still have some time. Okay, so please start doing some prelim questions. Okay, now let's not wait anymore. So let's begin going through. Okay, the first few parts will be going through a bit faster so that we have more time for the later parts. Okay, so the first question here. Now I have some annotations here. You all can copy down. Now as I go through, if you want to take a screenshot, please go ahead as well. Okay, or you can take once I finish the page. Okay, with all my annotations and all. Okay, so maybe after I finish one page, I'll give you time to just screenshot this. All right, now first thing, now which two elements react together most vigorously? Okay, so if we are looking for elements that react most vigorously, you must find the most reactive elements. Okay, so if you look at the list of elements, you have metals, potassium, copper, magnesium, aluminum, lithium. So these are the metals, and most of them are in your reactivity series, except maybe lithium. Okay, so which is the most reactive then? Is it potassium, the top of the reactivity series, or is it lithium? What do you all think? Potassium, right? Okay, because other than the reactivity series, you must also remember your group 1 periodic trend. So going down the group is more reactive. So lithium is at the top of group 1, is the least reactive of the group 1 metals. Okay, so definitely potassium. And we have iodine and chlorine. Okay, so they have really put it so nicely. Group 1 are metals and some halogens. Okay, so between iodine and chlorine, it has to be chlorine. So potassium and chlorine. Okay, the most reactive metal, the most reactive non-metal. Okay, now which element bleaches damp blue litmus paper? So this is the bleaching effect is unique to chlorine. Okay, in fact, I can use a red litmus paper to test for chlorine also. Okay, but the one actually in your syllabus is use a blue litmus paper. By right, it should turn red, but after a very short while, it bleaches white because that's the bleaching property of chlorine. Okay, but if you just use a red litmus paper, it doesn't turn color, but you get bleached white. Okay, so the bleaching effect is still there. Which element forms positive ions with different oxidation states? Okay, so this is a property of transition matter. And which one here is a transition metal? It has to be copper, right? I already put it aside. Copper 1, copper 2. Okay, some of you may not know that there's copper 1 ion, but there is. Okay, so anyway, out of all these lists of metals, there's only one in the middle block of the periodic table. So it has to be copper. Okay, as I go through any question, just put in the chat, huh? Now, which element forms an amphoteric oxide? Okay, so remember your ZAP, zinc, aluminium, lead. Okay, so this is pretty straightforward. We only have aluminium. All right. Last one, which two elements form ions with the electron arrangement of 288? Now, this question, I don't know whether you saw my answer, but can you let me know your answer? Which two elements form ions with the electron arrangement of 288? Very interestingly, I think we had this question in our prelim paper, and there are quite a number of students who got this wrong. Very similar question. Huh? Robertson, you sec 2 ah? Okay. Uh, what are you doing here? Okay, welcome. It's good to learn chemistry ahead. Prepare yourself 2 years ahead. Okay, sure. Great job, Robertson. But real question, what? Oh, okay, can. Robertson, you finished your exam already? Should be these 2 weeks, right? Yeah, finished already. Okay, so yeah, great to learn some chemistry. Yeah, you get exposed to it. Okay. So the rest, well, can I have your answer? Okay, great job. Thank you. Yep. Okay, so it's potassium and chlorine again. But I was very shocked when I saw many students couldn't do this question because this is just atomic structure, like one of the early topic in Sec 3. Okay, so from the periodic table, if you find potassium 2881, there's a electronic configuration of uh a potassium atom. Okay, and you will lose that one valence electron, so you lose this electron and becomes 288. Well, on the other side, on the other hand, chlorine 287, and then it gains one more, so 288. Okay, so potassium and chlorine. Yeah, so I'm just gonna, I don't know, you can just take a screenshot if you want. For a few seconds. Robertson, so far you understand what I'm talking about? I don't think so. Okay, let me move on. Okay, now what we have here, we are supposed to take which one is true, which one is false. Now you see, even for O-level questions, we can have true, false. Seems like some primary school question. Yeah, but of course, the concept tester is O-level question, right? So the most unreactive group contains only non-metal. Now, so that of course refers to the noble gases, group 18. Okay, so that has to be true, right? Because group 18 noble gas, they are all non-metals. Okay, so yes, true. Now, melting point increases down period 2. Now, I have already put aside period 2 in your periodic table is lithium all the way until neon. Okay, so does the melting point increase or decrease? So you think about it from the left, which is the metals exist as solid. Okay, most of them. And to the right, noble gas, fluorine gas, oxygen gas, nitrogen gas. Okay, so from here you can tell the melting point. Right, it must have decreased. So this is false. Third one, atoms lose electrons more easily down group 1. So this is actually related to reactivity. Okay, when an atom loses electrons more easily, it's more reactive. So we know reactivity trend for group 1, right? Reactivity increases down the group 1. Reactivity increases up group 17. Okay, so they're opposite. Right, so for group 1 metals, since reactivity increases down the group, okay, that means that they lose their electrons more easily. Okay, so that is true. Now, the strongest non-metal oxidizing agent is at the top of a group. Now, what does it mean by strongest oxidizing agent? Okay, non-metal we know. Strongest oxidizing agent. So, oxidizing agent is a substance that oxidizes another substance. Correct? And itself is reduced, right? It oxidizes another substance, itself becomes reduced. Okay, so what in terms of redox, okay, reduction means what? Reduction means gain of electrons. Gain of electrons. So if we are talking about oxidizing agents in a particular group, okay, it has to be group 17. Okay, fluorine being the strongest oxidizing agent because it's the most reactive on group 17. It gains one electron the easiest. Okay, that's why it's the strongest because it gains the easiest. It gains the electron the easiest. Okay, so it's the strongest. Huh? Oxidizing agents are like acidified potassium manganate 7. That is correct. Halogens are also oxidizing agents. Okay, because themselves they get reduced, right? From the elements, they become ions. Okay, for example, right? So fluorine, what happens? Fluorine gains 2 electrons to become fluoride. Isn't it being reduced? Oxidation state from 0 to -1. Why got Fe? F minus. Okay, 2F minus. Okay, so oxidation state decreased, so it must have been reduced. So it's an oxidizing agent. It oxidizes another substance, itself is reduced. Okay? So just to add on the question, then what is the strongest reducing agent? We are talking about elements, elements in the periodic table. So of course there are other oxidizing agents like the ones you of course know, potassium manganate 7. Okay, there are other reducing agents like potassium iodide. But now I'm talking about elements in the periodic table. So which element in the periodic table is the strongest reducing agent? What do you all think? Hmm. No. If you choose lithium, is it the most reactive in group 1? If it's the strongest reducing agent, it must at least be some of the most reactive. And out of group 1 metals, it has to be the one at the very bottom of group 1. Okay, at the very bottom of group 1, that is the most reactive, therefore the strongest reducing agent. And cesium is not the lowest. Okay, so if you have a periodic table, just take a look at that. Just share this. Okay, cesium is the second last. There is a francium. Okay, can you see that? Fr, francium. Okay, so francium will be the most reactive reducing agents. The strongest reducing agents, the most reactive group 1 metal. Okay, so this is francium. Did I spell correctly? See, see. Yep. Okay. Okay, let's move on. Question 2. Now, question 2 on crude oil. So crude oil, remember that you do not need to go and memorize like what is the function of each fraction. Okay? Sometimes it's provided in your notes, but you don't go and memorize what's the function of each fraction. All you need to know is how it works, how this fractional distillation work, and generally, how are they separated. Okay? So it has to be by the boiling point, right? Because it's fractional distillation. Okay? So we are supposed to describe how it works, how to separate. Okay, so other than being general how it works, right? So the question asks to separate propane and octane. Okay, and you can see from the diagram here, propane is at the very top, octane is here. Okay, so describe how fractional distillation separates propane and octane. So you have to describe your fractional distillation of your crude oil. So we don't start off with vapor, we start off with crude oil. Crude oil is in which state? Before it becomes a vapor, it is crude oil, a type of fossil fuel which is in the liquid state. So before it becomes a vapor, it must go through the furnace. Okay, vaporize that, let the vapor enter the column, then it will start to cool down and condense, right? They will start to go up and cool down. Because in the furnace, in the column is quite big, so they have different temperatures. So the higher you go, the cooler it is, okay? Like what I mentioned here, hottest at the bottom, hottest, coolest. Okay? So as it goes up, it will cool down and condense. And depending on their boiling point. So if they have reached that boiling, if the gas goes there and reach that boiling point, touch the cooler surface, condense, and then it will be extracted out. Okay, but again, the question is on propane and octane. So I need to be specific in my answer, not just everything general. Okay, so Talk about propane going up to the highest point, where it's because it has the okay, we don't need to explain. So it goes up to the highest points. Okay, that is because of its lower boiling point. Okay, but octane has a higher. Okay, we still need to explain a little bit here because we need to show how it separates, right? So octane has a higher boiling point, so it has to be is obtained at a point that is lower than propane. Okay, therefore I can separate them. All right, so the first part is about making it into a vapor, passing it into the column, and then they will start to cool down and condense as they rise up. Okay, so once they reach the particular point in the column where it's their boiling point, and then they will start to cool down, they will start to condense because they will become a cooler surface. All right, and propane compared to octane, it has a lower boiling point, so it's higher at the top. But for octane, it has a higher boiling point, so it will be found below propane. Okay, so this is the part here. You need to differentiate where you get them because of the higher boiling point. All right. Okay, so make sure you go through this process. They can ask you in different ways, but as long as you generally have the idea, okay, that it turns to the gas and enters the column, separated by the boiling point, and then answer to the question. Did the question ask for something specific? Propane, octane, or something else? Now I move on to part B. Explain why propane and butane leave the column in the same fraction. Now you must understand that crude oil is a mixture of hydrocarbon. There's a lot of hydrocarbons in it. And even after doing this fraction distillation, each of these fraction is still a mixture. Mixture of many hydrocarbons. It's just lesser. Okay? So they are still in the same mixture because their boiling points are quite close to each other. If you talk about propane and butane, of course, I won't memorize their boiling point. I don't know their boiling point. But just based on what you know, propane has 3 carbon, butane has 4 carbon. So their boiling points can't be too different. Okay? So it has to be because the number of carbons are quite close to each other. Therefore, the boiling points are very similar. Okay? So similar number of carbon atoms, therefore similar boiling points. Okay, I move on. Take a screenshot of this if you need. Can we say since they have almost the same boiling point, they both exit in the gaseous state out of the column? You don't say that's almost the same. Let's say they have very close boiling point, but the rest are okay. Yeah, let's say they have very close boiling point. Okay, move on. All right. So coming to this, what is the molecular formula of propane? And then the empirical formula. Okay, you must know the difference between these two, and there are still students who do not know what exactly molecular formula is. Okay, so for propane, is an alkene, right? So general formula CnH2n plus 2. So propane, 3 carbon. So N equals to 3. So C3H8. What about empirical formula? Empirical formula is the simplest ratio of the atoms in the molecule, right? But 3 and 8 is already the simplest ratio. I cannot simplify this anymore. So therefore, this is still the same. Okay? Now, but for octane, C8H18. So I can actually divide by 2, right? So C4H9. Okay? So molecular formula shows the total number of atoms of each atom of each element, okay, in the molecule. If I tell you I have this, what formula is this? What is this formula on the right? The type of formula. I'm not asking you to identify what substance this is. What is this type of formula called? Hmm. Structural formula, condensed formula. Okay. Displayed. No, this is not displayed. Displayed means you have to draw it out. So you can consider this as a structural formula. Okay? This can also be called chemical formula. So what is the difference between this and this? Okay, other than the actual number, but is this considered molecular formula? This is not considered molecular formula, right? Because molecular formula means that it tells you the total number of total number of atoms of each element. Okay, so therefore the molecular formula for this ethanoic acid is C2H4O2. That is the molecular formula. And the empirical formula, CH2O. Okay? So this is for ethanoic acid. Okay, now moving on. So for octane, okay, it's the main component in petrol used in cars. Okay, so they say that some cars use LPG, liquefied petroleum gas, and the main component is butane. Okay, so these are just some background information. Now, so both octane and butane are burnt. These are the enthalpy change of combustion. Okay, and the question asks you why the enthalpy change of combustion for octane is more negative. More negative means produce more heat, right? Produce more heat. Okay, it's exothermic. Both are exothermic, but the combustion of octane is even more exothermic. It's more negative. Okay, but we need to suggest reasons why. And this one is really a bit about logic. You try to explain, right? Under complete combustion, both will produce only two products, carbon dioxide, water, for complete combustion. Okay, so let us just try to balance these equations. If I burn octane, C8H18, so how should I balance this equation? So I should have 8 carbon, okay, and I should have 9 water, but that makes how many oxygen? This is 16 plus 7. 16 plus 9. 27, right? 25. 16 plus 9, 25. Okay, 25. But I have even number of oxygen. Okay, so what you all can do is 25 over 2. You put a fraction or put a decimal. But we cannot. When we do actual chemical equations, we cannot put fractions. So what you need to do is to multiply everything by 2. Okay? So when you do that, the first one you multiply by 2, so this is 2. The second one is 25 over 2, so that becomes 25. 8 and 9 becomes 16 and 18. Okay? And then there's a balance equation. Now this is not part of the question. I'm just trying to go through this balancing of equation with you guys. Okay? So for butane, same thing. Okay, for carbon, you see how I balance this chemical equation? You look at those elements that appear ones on each side of the equation first. So carbon first, then the hydrogen, I have 5. Then I look at oxygen. I have 8 plus 5. That's 13. Okay, so again, I need 13 over 2. So I just multiply everything by 2. Okay, so this is 2. I have 13, 8. Great. This is 13, 8 CO2 plus 5. No, this is 10. 10 water. Okay? Now, so now if I compare, for every mole, okay, for every mole of octane, okay, you produce 5,470 kilojoules of energy. Okay, but for butane, only 2,880. Okay, but it's quite obvious, right? The reason is because we are forming, okay, now, okay, we may not actually be able to explain this very clearly, but just based on some science logic, right? If we are producing a lot more carbon dioxide, a lot more water, and they tell you it's exothermic, then simply explain that, okay, so forming a lot more bonds in carbon dioxide and bonds in water molecules, so that produce a lot more energy. So you try to reason it out. Okay, but it still must be in exothermic terms lah. Okay? So it has to be release more energy as compared to uh butane. Okay, so what you can write here, first one, talk about producing more moles of carbon dioxide and water. So we have 16 moles of carbon dioxide, 18 moles of water as compared to burning propane. There's a typo here, just change it to change to butane, is butane. And with this greater number of moles of the two gases, therefore, you must have released more gas, you must have released more energy. Okay, release more energy to form the bonds because they tell you it's exothermic. Okay, so our focus here should be talking about the products. We don't need to talk about, we don't really need to talk about the reactants because reactants, to break the bonds in the reactants, you need to absorb energy. Okay, but because the focus here is being exothermic, okay, so we can focus on forming the products. Okay, any questions here? Now, I'm going to move on. Part 2, calculate the mass of butane and give the same amount of that gives the same amount of energy when combusted as 50 kilograms of octane. Okay, do you all get 48.3? So we have this information, 50 kilograms of octane. So of course, you just go and find out the number of moles. Okay, what can we do with the number of moles? So you look at the table here again. Let's use, okay, let me just circle it. Enthalpy change here is in kilojoules per mole. Per mole of that alkane. Okay, so if we can find out the number of moles of octane, we just multiply by this enthalpy change per mole. That will be the enthalpy change. That will be the amount of energy produced. Okay, so let's do that. So we find number of moles, 438.60 mole. Okay, multiply by the energy, 5470. Okay, so you should get this amount of energy produced. This is in kilojoules, based on the question, based on the data. Okay, and they say that it will produce the same amount of energy. So you do that, you reverse this whole process, you divide by 2880. Okay, you go and divide by 2880. To find out how many moles of butane there are. Okay, then just find the mass. Right? I'll just leave this here for a few seconds. Okay, take a screenshot for this. Okay, I want to move on. Now, this is for electrolysis. Okay, so combined science students, you don't need this. Right, so for this question, now we need to fill out the missing information. So for the first two, we are using carbon, which are inert. Okay, so our only concern is what is inside the electrolyte. So we have H plus, Na plus, we have OH minus, we have Cl minus. Okay, both the same, but the difference is that we have concentrated solution for number two. Now, before we even write out anything, you must be able to identify what is the negative electrode, what is the positive electrode. Okay, in an electrolytic cell, negative electrode is the, yeah, let me know, what is the negative electrode in an electrolytic cell? Is it the cathode or the anode in the electrolytic cell? Negative electrode in the electrolytic cell. No, that's not correct. It's not the anode. Okay, that's why, you see? Okay, by now you need to know already. Negative electrode in the electrolytic cell, this is the cathode. And the positive electrode is the anode. Okay, so cathode attracts cations. Anode attracts anions. Okay? So anions are attracted to the positive electrode. Okay, they are unlike poles, unlike charges. Okay, so you must get this correct first. So the first one, we have sodium and hydrogen ions attracted to the negative electrode, the cathode. So it has to be hydrogen being discharged. But the question asks you, what is the substance formed? What is formed? Please do not write hydrogen ion. Okay, if you write hydrogen ion, then that is wrong. Okay, because they ask you for product, they ask you for substance form. Hydrogen ions is not formed. Hydrogen ions are attracted, which is then discharged to form hydrogen gas. You can just leave it as hydrogen. Okay? And at the anode, it attracts anions. So because this is dilute solution, no concentration effect, so it will be the hydroxide ions being discharged. Hydroxide ions form which substance? Hydroxide ions are preferentially discharged to form what? Guys? Yes, thank you, Aris. Okay, you just need to write oxygen. That's the main thing. Okay? That's the main thing. But of course, in your equation, there's oxygen and water, yes. Okay, but you can just write oxygen will do. Now, second one, concentrated solution. So concentration effect will affect the anions. So we are looking at these two. Okay, so instead of hydroxide ions being discharged, chloride ions will be discharged, forming chlorine gas. Okay, hydrogen still gets preferential discharge. Now, the last one, copper and copper. So now we have two reactive electrode. Okay, then what happens at okay, we talk about the anode first. What happens at the anode? What is being formed? If we have reactive electrode, what happens at the anode? Okay, you all must remember anox, red cat, anode oxidation, reduction at the cathode. Okay, so at the anode is oxidation. The reactive electrode at the anode will get oxidized. Okay, the electrode itself gets oxidized. So copper becomes copper ion. Okay, copper becomes copper 2 ions. You mentioned the charge. At the cathode is where reduction occurs. Okay, but even though we are using reactive electrode, this copper electrode is not going to be reduced. You cannot have a metal become reduced. Okay? If it becomes reduced means that the metal ion is negative charge, which is never the case. Alright, so instead it will be the copper ions, Cu2 plus, being preferentially discharged to form copper metal. But you can simply write copper. Okay? Now, use the example in the table to explain the difference between inert electrode and an electrode that is not inert. Okay, so not inert, we are talking about number 4, the reactive electrode. Okay, so those are not inert. Now, how do we compare? Which two experiments do we compare? In order to compare the electrode, remember when you do your science experiment, it must be a fair test. I want to compare the electrodes, so my electrolyte must at least be the same. Okay, so I need to choose this and this. My electrolyte must be the same. Then my electrodes different. So I can only choose 3 and 4 for comparison. I cannot choose 1 and 2 because electrolyte is different. And then electrodes are the same. So that we cannot use that. Okay, so we can only use 3 and 4. Electrolyte is the same. We only change the electrodes. So comparing 3 and 4, okay, I need to explain the difference. So if it's not inert, means it's reactive, like number 4. Then what will happen to it? Okay. Then if it's inert, what will happen to it? Okay, so we need to describe those. Alright, so these are your answers. So if you look at silver, now silver, sometimes when you see silver, you might think that it's reactive. Yes, provided our electrolyte is also silver containing. But in this case, number 3 is a bit strange. That's why they just give it to you. Okay, because we don't really see such example in our questions usually. Okay, so whenever we use silver electrode, the electrolyte is silver containing, but now it's not. So they tell you that the products are copper and oxygen. So which means that these two are inert. Nothing happened to them. There's no silver in your products. Not silver ion, not silver metal. Okay? So what happens here? So silver is inert. Okay, so the positive electrode, which is the anode, does not undergo oxidation. Unlike what we went through in number 4. Okay, the copper went through oxidation. That is the main difference. Okay? Now, I move on to the next one. Describe the change that would be seen at the negative electrode during experiment 3. So what happened in experiment 3? Negative electrode, right? So that's the cathode. Okay, every time I see negative, positive, I will just write down cathode or anode. So I don't get confused. Okay, so at the cathode, what will you see? So we already know, right? Negative electrode, we see copper. Okay, but what will we really see? So in terms of observation, right? You tell me color, tell me whether there's effervescence. Okay? So in this case, what we have here, okay, you can just say the electrode grows in size. This is sufficient. Why? Because copper is sorry, wait, this is experimental. Okay, no. This one you need to tell me the pink solid is formed. Sorry. Because our electrode is silver. Okay, if our electrode is silver, then you say a pink solid or reddish brown solid is formed on the silver electrode or the negative electrode. Okay? So for the copper, it can be pink, can be reddish brown or brown. All are okay. All of them are accepted. For number two, write ionic equation at the positive electrode in experiment 3. Okay, so this is the anode. What is happening at the anode? For experiment 3, so experiment 3 is the one they have given. So they tell you that oxygen is formed. So we just need to write the equation to form oxygen. Okay? Now this equation you have to memorize. Please go and memorize this equation. Okay, go and memorize. Alright, that is the hydroxide ions being discharged, forming oxygen gas. Okay? Describe and explain the color change of the solution in experiment 3. What is the color change? The solution here is copper 2 sulfate. Copper 2 sulfate is blue. Okay? But what happened to it? You see what we are forming here? Copper. That's because copper ions are used up. So they have been used up. Their concentration decreased. Okay? So the blue solution fades. Okay? Blue solution fades, or say become lighter, or you can say it becomes colorless. That's because there's a decrease in concentration of copper ions as they are discharged. All right. You must identify the initial color first, so don't forget you identify it's blue. So blue solution fades because of the decreased concentration of copper ions, copper 2 plus ions. Reddish brown, you are talking about this part, the copper, is it color of copper? Yes. So color of copper, it can be pink, can also be brown or red brown or reddish brown. Okay, either one. Three of them. Okay, I'll zoom out this page. Hmm. Can we explain what are inert electrode and reactive electrode before coding? Yes, you can, Aris. Yes. Any other questions before I move on? Okay, I'll move on. Now, question 4. This is actually our syllabus already. Okay, so this is the blast furnace for iron. So I will only go through the parts where it's still applicable. So all these actually not so applicable anymore. The one that's applicable is the last question on alloys. Okay, so I'll just go through these parts. So molten iron from the blast furnace. Basically, this blast furnace is to obtain iron, pure iron, or okay, maybe not so pure, iron from the iron ore. Okay, you know extraction of metals, right? So this is what we do for iron. It was last time in the syllabus that it was removed. Okay, so they say this molten iron contains carbon, so it's not so pure lah. Okay, so the carbon is removed, but after removing, they add it back. Okay, and it's carefully added to make steel. So explain why carbon is added to iron. Okay, so basically we got the iron to get the pure iron. We remove the carbon to get the pure iron. But then why do we add back carbon? Why do we do that? So basically that is alloying. What is the purpose of forming an alloy? That is what the question is asking about. Okay, why do we add carbon to the iron? That's because we are forming alloys. And what is the reason to do that? So you must talk about the good thing about the alloy. Okay, how do you describe how good alloying is? So you talk about, yeah, this is the first part of the answer. You can start off from here. You talk about when adding carbon atoms. Okay, this is a standard phrasing. This is a standard phrasing. When you talk about alloys, they are stronger, they are harder because of this. Okay, so when we add these carbon atoms, they are different sized atoms. Okay, so that will disrupt the orderly arrangement of the pure iron atoms. Therefore, the layers of atoms cannot slide over each other easily. Okay, so this is a standard phrasing. You must have this. You can just start off from where I bracketed. The first part is basically just repeating lah. Okay, but we have not completed the answer. This is just 1 mark. Then the second part asks you, why must it be added carefully? Okay, so this is an issue when we do alloys. Okay, when you add different, okay, you all know steel, right? Steel, there are many different types of steel. Okay, stainless steel, maybe you only know stainless steel, but there are different types of steel. Some steels are stronger, some steels are not as strong. That is because depends on how much carbon they add in. The more carbon they add in, the more brittle the steel becomes. Okay? And okay, I'll move on to question 5. Okay, can we say that carbon and carbon atoms are added orderly arrangement of iron? Orderly arrangement of the iron atoms. Iron atom. Orderly arrangement of the iron atoms will be disrupted. Iron atoms, not iron layers. Okay, already some missing parts in your answer. First thing, you did not tell me why would the layers of iron atoms be disrupted. You did not tell me about the different size atoms that is missing, so you did not get that 1 mark. Then, when much carbon is added, iron layers will be too far apart. It's not about being too far apart. Okay, it's not about being too far apart. It's just that when they become more disorderly, then it's easier to break. That's it. Yeah, it's not about the iron atoms being too far apart. No. Yeah. So just simply say that it becomes brittle will do. Okay, no need to further explain that. Okay, question 5. Now we are supposed to draw this structure of urea. Okay, so urea here, they have given you the formula. Okay, so how do I draw this formula? NH2 bracket 2 and then CO. I must start off somewhere. Which one do you think is the atom in the center? So a lot of times is carbon. Okay, whenever you see carbon, right, usually that will be the one. But of course, depends on the compound. Okay, so The carbon is in the middle, and then we have two groups of NH2 bonded to the carbon. Okay, we just need to show outer electrons, right? Okay, so show you the answer here. So carbon right in the middle. Okay, oxygen still doing its own things. Oxygen double bond, double covalent bond with the carbon. So sharing 4 electrons in total here. And then two groups of NH2 bonded to the carbon, each of them sharing 1 electron to the carbon. Okay, if you have tried this question, what you might miss out is always this lone pair of, no, 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 always these unbonded electrons that students will miss out. You may get the structure correct, but if you forget unbonded electrons, then you lose mark, and that's wasted. Okay, because getting a shape, the orientation, the position correct is already difficult, and then you forget about all these unbonded electrons, so you wasted that time. Okay, and always read the question. If they ask you to draw only valence shell, only valence electrons, do that. Okay. Now part B. Now wait, this DEF, right? Okay, they say that this DEF, diesel exhaust fluid, okay, it contains urea. Then this DEF is injected into hot exhaust gases. High temperature causes the reaction here. Okay, so reaction one. So the urea react with water to form ammonia carbon dioxide. The ammonia then react with nitrogen oxides in the exhaust gas. So ammonia reacts with nitrogen monoxide or nitrogen dioxide. Okay, so you try to understand the question already. Now, they say that if the tank becomes too hot, it could cause an explosion. Okay, so it should be stored away from the hot engine. So why will it cause an explosion when it becomes too hot? So actually there are already hints in the question. Okay, so they say that high temperature causes something, causes this reaction. So what does it got to do with this reaction? That can result in an explosion. Okay, so you just imagine, right? Okay, this urea is a liquid state. This is liquid. This is water. Water is also liquid in this case. Now, then these two what? These two are gases, right? Gas and gas. So what happens? No, it's not. It's not about ammonia being explosive. It's not. Now just imagine you have liquids, okay, then suddenly you produce a lot of gas. What happened to the space occupied? Expand. Okay, because now you have a lot of gas, a lot of gaseous particles, and they will need to take up the space in that tank. Right? It's just like blowing a balloon. The more you blow it up, the more likely it's going to explode. Okay? So there's a very high pressure inside basically. Okay, so we talk about the number of moles here. So it reacts with water when the temperature is high, right? Temperature is high, it reacts with water, forming the two gases. So 1 mole of urea can form 3 moles of gaseous products, ammonia and carbon dioxide altogether. Okay, then the main thing is the last part. Higher pressure, therefore cause explosion. Okay, right. I will move on. Have you taken a screenshot? Okay, next question. Now, state with reasons two benefits to the environment of using DEF to treat exhaust gas. So we're supposed to use equation 2 and 3 as mentioned. Refer to the reactants and product. Okay, so they give you quite a bit of hint. So reactants, products of 2 and 3. So let's go to that. How, again, how two benefits to the environment. How can this be beneficial? So you think about it. Okay? Think about the reactants, the products, because they tell you to do that. Hmm. Okay, so one of the things that is very obvious, these two, nitrogen monoxide, nitrogen dioxide, what are they? You should know, right? These two are oxides of nitrogen, they are air pollutants. And after the reaction, what are we forming? Harmless nitrogen gas. So, isn't it a benefit? Okay? We are converting air pollutants into harmless gases. Okay? That is one. So you have to think of the second one, which is a bit harder, a bit more difficult. So it is the ammonia itself. Ammonia is a highly soluble gas. Okay, ammonia is a highly soluble gas. So one way you can think about it is if it's dissolved in water, it can cause the formation of aqueous ammonia, which is alkaline. Okay, so that increase the pH. Okay, so those are possible answers. Okay, so ammonia soluble in water, it can increase the pH of water bodies or maybe even soil. Right, if all these ammonia are produced, then it starts to rain and then it dissolves in the rainwater, so causing alkaline soil, which is not that beneficial to the plants. So these are things that we can consider lah. Okay, we are removing the ammonia. And the second one is to convert harmful oxide of nitrogen to harmless nitrogen and water. Okay, part 3. Suggest and explain one reason why DEF does not solve all environmental problems. Okay, now that we have mentioned, we have benefits, we remove ammonia, we remove harmful oxides of nitrogen, but is there something else that is still causing harm to the environment? So we need to go back to our equation. Okay, think about something. Did they give hints? No, no hint, right? So suggest, explain, no hints. Okay, carbon dioxide, yes, what about that? Okay, so you see equation 1, what do we have? We have carbon dioxide. What does that tell you? Okay, so carbon dioxide is produced and nothing else happens to it. So which means that it's released to the environment. But carbon dioxide is not an air pollutant. So what is the environmental problem? Correct. Don't stop there. It's a greenhouse gas that does what? Global warming, increased temperature of the earth, and then does what? Okay, you must give me the full picture, okay? So carbon dioxide is produced. Okay? Contributes to global warming. And then okay, actually all this no need. Don't need. Okay. Not so important. If you can tell me global warming and increased temperature, that's fine. Then go on to say that it leads to melting of ice caps or leads to rising sea level. That's sufficient. Okay, we just give you more examples in case you have written that. Okay, so don't just stop at, oh, it's a greenhouse gas causing enhanced greenhouse effect. And that's not going to score you any marks. Okay, enhanced greenhouse effect leads to global warming, and we're still not done. So that causes melting ice caps, glaciers, and then that is where you stop. Okay. Okay, let me move on. Part 4. Write an overall equation for the reaction of urea with NO2. Now, you see, this is with NO2, very specific. Where did this substance react? Where did urea react with NO2? Okay, I'm gonna erase all this. Where did urea react with NO2? Okay, so we are looking at urea, which is this NO2 here. So which means that we want to focus on equation 1, equation 3. How do I make it into one equation, right? We're supposed to write overall equation for that urea reaction with NO2. So usually when we write an overall equation, we'll add up the reactants and then we add up the products. Okay, but in this case, we cannot just add up. We need to eliminate something. For example, ammonia. We have 2 ammonia here. We have 8 ammonia here. Okay, so it was the product which then used in the reaction 3 in order to form nitrogen and water. So which means that this whole equation, number 1, I need to times 4. So I will have 4, 4, 8, 4. Okay? Then, so with this, I can eliminate ammonia. Alright? You see, I also have water. 4 water, I have 12 water, I remove 4, so that's left with 8. Okay? So can you see? You are forming your overall equation already. Alright, so the rest are part of the overall equation. There's nothing else to cancel. Okay, so we have 4 urea with 6 nitrogen dioxide, forming 7 nitrogen, 8 water, and 4 carbon dioxide. And that's how you do it. Okay? So you must equation. Okay. So this is a final, this is an overall equation. You must remove the ammonia. Okay? Now, part C. Now, part C is just stoichiometry. Okay, we have 500 cm cube bottle of DEF, and the bottle contains 160 grams of urea. So what's the concentration? Okay? So concentration is mole over volume. Right? We have the volume. Okay, we just need to find the number of moles. So 160. So you use 160, you divide by the molar mass. What is the molar mass? Okay, so you have the formula. Just go and find your periodic table. Okay, let me just zoom this in. It's pretty big. Okay, so you find the formula of the urea. Go and use 160 divided by the molar mass. Okay, so with the number of moles, you divide by the volume because number of moles over volume gives us concentration. Then you get 5.33. Okay. Any questions? Okay, if not, I will go to section B. Okay, now, you just want to take note that in this 2021 paper, right, there is a section B here, and they ask you to answer 3 questions. Okay, the exam format has changed, so this is not the latest exam format. So you refer to the latest one in the 2024. Okay. So you know your exam format, right? Okay, you all must know, Fine, I did it for you. For the pure students. Let me see. Yeah, so you read here, this is your exam format. So for those who still do not know, right, section B in your latest syllabus will only have two questions, and it's just either or. Okay? All the rest of the questions are all in section A, that's it. And then there's a database question in section A. And then section B is just an either or question. Each each of them is 10 marks, that's it. Okay, compared to last time, uh section B, there are three questions you are supposed to answer, and then it's a bit confusing. That's why they changed it also. Okay? Alright, so let's go through this question 6. Now, yeah, this is one of the questions I want to talk about. I think the topic of acid and base, right, especially the concept on strength of acid, concentration, basicity, all these are very important concepts that all of you must know. Okay, so what we have here, okay, they tell you that, you read the first part here, solution of different acids of the same concentration can have different properties because the concentration of hydrogen ions may be different. Okay, so even though the initial concentration of acid is the same, but if the concentration of hydrogen ions are not, then it's not the same. Okay, just look at some examples. Okay, I have some notes here already, so you can copy all this down. Hydrochloric acid, monobasic, strong acid. Sulfuric acid, dibasic, strong acid. Acetonic acid, monobasic, weak acid. Okay, if I just compare, if I just look at 0.01, 0.01, 0.01, acid concentration is the same, but hydrogen concentration is not the same. Which by now you should already know this very important concept, because strong acid means ionized completely when dissolved in water. Weak acid ionized partially, so you can see for acetonic acid very low as compared to the strong acids. Okay? Even if they are strong acids, you still need to look at their basicity, monobasic or dibasic. So if sulfuric acid, it has twice the concentration of hydrogen ions. So it's even more acidic. Okay? Now, then we have these equations below. So you read this equation, basically to write the equations later. Okay, but maybe we'll come back to this later. Okay, we'll talk about the first question. Which acid fit the general formula HA and which do not? Okay, so HA, right? Let's look at this part here. The general formula of acid is HA. But when you put it as HA, it means that it is monobasic. Because there's only one hydrogen. It's not like H2A. So HA means monobasic. So which one does not fit? It has to be sulfuric acid. Okay? The rest will fit. So hydrochloric, acetonic fits because they are both monobasic acid. It's a different color. Both are monobasic acids. You can elaborate a bit more. Produce one hydrogen ion per molecule. But sulfuric acid does not. Okay, because it's dibasic, produce two hydrogen ions per mole. Okay? Never go and just write the formula. Oh, sulfuric acid is H2SO4. So it's different from the formula HA. Therefore, does not fit. No. Talk about the science concept. Okay? Dibasic, monobasic. The concept is basicity. All right. So now we want to construct the equation with group 1 carbonate. So group 1 carbonate, such as sodium carbonate, right? So formula is Na2CO3. Okay. So we are supposed to use Ha as the general formula of the acid and M for the metal. Okay, so everything is generalized. We don't need to specify, but we know it's group 1. Okay, so we know the formula of the carbonate M2CO3. Okay, so our equation M2CO3 reacts with Ha, because they tell you it's Ha, right? You form your salt. Now, because M metal is the metal is group 1, so +1. A is also -1, the charge. So that's why the salt is just Ma. Metal in front, metal ions in front, and ion behind. Okay, not Am, Ma. The metal must be in front. Okay, and we form carbon dioxide and water as well. And make sure to balance it like a normal equation. Alright, next. Write equation for the reaction for calcium with ethanoic acid. Okay, then we will show with reference to the value of x why equation 2 agrees with your equation. So, equation 2, it shows this reaction, right? Acid with metal. That's what we're trying to do. Calcium with the acid. So we write our equation first. We already know what are the substances, calcium and ethanoic acid. So let's write that. Okay, calcium with ethanoic acid, forming the salt calcium ethanoate and hydrogen gas. Okay, but we are not done yet. We are supposed to show with reference to the value of x why equation 2 agrees with your equation. So using our equation, we of course can tell that x will be 2. Okay, so we have you can explain it in different ways, of course. These are just some examples of how you can explain it. So if x is 2, okay, then equation that is given to us will look like this. And therefore this one, you can compare it with the equation that you have written. Okay, so that's one way to write it. Or you can put it in words. So if x is 2, okay, that is because calcium ion has a charge of +2. Okay, you can explain it in different ways. Okay, I'll move on. Now, next. A student looks at the data in table 6.1, which is this one. Okay, I just brought it down here. It suggests the following relationship. This is pH is inversely proportional to initial concentration of acid. So we use the data to show that this relationship is not correct. Okay, so what can we tell? So initial concentration of acid, if let's say I use all 0.1, like what I did just now. 0.1, sorry, 0.01, and we see that the pH 2, 1.7, 3.4. So we cannot use, so this equation it does not apply, right? Because I have used the same concentration of the acid, but the pH is different. So this equation doesn't work. Okay, so that's one thing you can talk about. Okay, but you see, this is a 2 marks question, so this answer is not sufficient. So another thing that you can talk about is this one that is already written here. So if let's say I increase the concentration of hydrochloric acid by 2, we double that, the pH half, did not become half. Okay, because the inverse relationship, right? If the denominator is 2, pH should be half, but it was not. Okay, so that's something that you can include as well. Okay, I move on. Take a screenshot later. Now, part 2. State and explain the factors that affect the pH of an acid. Now, I put the answer here, basicity and the strength, like what I mentioned at the very start. Okay, I mentioned this at the start when I went through the data already. Alright, so basicity, we have monobasic and dibasic. Okay, so even with the same concentration, the pH is not the same. Alright, if it's monobasic and dibasic. Now the strength of the acid, I use a strong acid, I use a weak acid. Okay, so they produce different pH even at the same concentration. So you see what I've done here is I have provided information in the question because that's what the question says. Using information from the table. So whenever you have all this, when they say use information, use the data, put down some values if there are. Okay, put down some values inside your answer. Do we have to say it's diabasic? Um, yeah, you can mention it's diabasic. That's why I didn't put it down. Uh, yeah. So hydrochloric acid is monobasic, sulfuric acid is dibasic. Okay, so you can put that down like that. So monobasic, that's for hydrochloric acid. Dibasic, that's for sulfuric acid. Okay. Okay. Now, moving on to the last part here. Use the data in 6.1 to help you. Okay, funny way they phrase it. Okay. But anyway, we're supposed to just fill up these 4 blanks in the table. Okay, so you look at the concentration of the acid, hydrochloric acid, 0.04. So what is the concentration of hydrogen ions? So because it's monobasic, so it's the same. Sulfuric acid is dibasic, so it's twice. Okay, 0.05 becomes 0.1. But what about the pH? So this predicted pH is not, even though they say, okay, it's predicted lah, it's not really an estimated pH because there are actually some hints in the table. Okay, again, use data in the table, right? So maybe there are some hints in the table. Remember, pH depends on hydrogen ions concentration. So if let's say I have 0.04, it's actually here, for sulfuric acid. Different acid, but hydrogen ions concentration the same. So this is 1.4. So it's not like I'm guessing. It's there. Sulfuric acid, 0.1. That's actually found in hydrochloric acid. Okay, so that's 1. But I'm not guessing. I'm not trying to find, 0.01 becomes 0.04. So the pH should decrease by how much? If you guess 1.5, 1.6, you don't get the mark. Okay, because here clearly shows that it's 1.4. Okay? Okay, I'll move on. Okay, I don't have much time. We might have to extend maybe 5-10 minutes. Okay? By right, we are supposed to end at 9. Okay, but let's finish the questions. Now, next one is on polymerization. So first thing, this is condensation polymer, right, as they mentioned. Condensation polymer. What is the relative molecular mass, the MR, of the repeating units formed in molecules A and B? Can you tell me how y'all do this question? How do y'all do the question? Do y'all draw it out, then go and start calculating? That is one way, which is what I think that many students will do it. They go and draw it out and start calculating. So if you do that, right, make sure your drawing is part of your answer. Okay, don't just sketch somewhere and that is not inside your submitted work. Right, it should be drawn there so that when you calculate your MR, it's clearly you are using the repeating unit that you have drawn. That's one way. Another way is, remember, this is condensation polymerization. In this process, you are losing water molecules. Okay? So we can calculate the MR of each of these monomer. Okay, so A is 90, B is 166. That's their MR. And because it's a diol and dicarboxylic acid, you will lose two water molecules. Okay, you will lose two water molecules. So the OH here will be gone, the H here will be gone, the H here will be gone, the OH here will be gone. So I just need to remove 2 times of water, which is 18 times 2, 36. Okay, then I will get the answer. All right. Then I leave the working to you. You can take a screenshot for this. Go and try it out yourself and calculate. Especially you see this kind of large, even though it's a simple molecule, they are still considered quite large in a way because you have many things to calculate. Okay, so you can make careless mistake, right? Okay, part 2. So molecule A has 2 alcohol groups, which we actually call hydroxyl group, hydroxyl functional group. So the alcohol groups can be oxidized by uh, the oxidizing agent, right? Potassium magnate 7. So it's oxidized to become COOH, carboxyl group. So we are supposed to draw the structure. Now, this is very important. Do not make the careless mistake. Molecule A looks like this. During oxidation, take note there is no loss of carbon atoms during oxidation. No loss or gain. No loss or gain. So the number of carbon must be the same. Okay? So one way to do this is, okay, you are given this condensed formula. So let's expand this out. Let's draw the usual way. Alright? So I have 4 times of CH2. So I have CH2, 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 CH2 in the middle. Then I have OH at the side. So when it becomes carboxyl group, this whole thing that I have circled, they will turn into carboxyl group. So I must still retain total of 4 carbon atoms. Cannot have more. Okay, because careless mistake, right? Some people will just leave the CH2 at bracket 4 here and eventually becomes what? Becomes like you have additional 2 carbon in the end. And that's wrong already. Okay, so that's wrong. Right? So let me just erase that. So you should not have additional carbon. So your structure could look like this. There's no need to draw like how they have drawn it. Just draw it like how you usually would draw it. Okay? Right, so eventually this one looks like this. The rectangle box is what's in the middle. So in this case, it's just this part left, which is CH2 bracket 2. Okay? Okay, I will move on. Now, part B. We have molecule C polymerized to make another condensation polymer. Now, this molecule C is different from what you would usually see. Because why? This molecule has different functional group on it. It has the hydroxyl group as well as the carboxyl group. So it can actually react with itself. Okay, you just need one type of monomer for the polymerization to occur. Okay, but it's still condensation polymer. It's still condensation polymerization. All right. Later I'll explain what this structure is for. So let's talk about the first one. Okay, how do you know this is polyester? Polyester means that it has a lot of ester linkages. That's it. Okay, you will be able to see a lot of ester linkages. How you name it is just up to you. But simply just write ester linkage. That's fine. Okay. Now, next part is to compare between condensation and addition polymerization. Okay, I need one similarity, two differences. So remember this molecule C, right? It can polymerize itself. It doesn't need a different one. Okay, it's different from the diol and dicarboxylic acid. I need two different monomers to polymerize because they have the same functional group on themselves. But if the functional group is different, then it can react with itself. So that is one similarity with ethene. Okay, addition polymerization just need one type of monomer. Okay, you can phrase it in this way. Repeated units, you just need repeated units of one type of monomer, either C or ethene. Okay, I just put at the side here. One type. Okay, I don't just put, oops. Okay, this is ethene molecule, just for your reference. You just need one type of monomer. Okay. Now, in terms of differences, so there are some things that you can talk about, such as what bonds you are breaking, such as whether you produce a small, I think most of you will remember forming of a small molecule like water. Okay, that is the most common answers that students wrote. Either you produce water or not produce water, because one is addition, one is condensation, right? But other things, we need two differences, right? So what bonds we are breaking? Okay, so for addition, we are breaking carbon-carbon double bond. For condensation, that one you have to be very careful. Go back to the diagram here. You see here, that's why this structure is drawn here. Not this. This one. What bonds are we breaking? We need to lose water molecule, right? So OH lost from the carboxyl group, H lost from the hydroxyl group. That's the bond that is broken. CO and OH. Okay? So that's just forming ester linkage, just like normal esterification. Take note, please go and go through this again on polymerization. Because last year they did not really test on this. So which means that maybe this year they might test. Last year, if you look at the TYS, only 2 MCQ question for polymerization. So this year, they might give more. Okay, especially all this drawing and explanation. Talk about the linkages and the byproduct only. No, I need two differences. What? Which one are we talking about, Aris? Linkages. You mean the linkage that is formed like ester linkage and then the other one doesn't have a linkage? Uh, you form ester linkage and the other one doesn't have a linkage. Difference between... I would not say that is a good answer, okay? Because the question is asking about the process of polymerization. The process of polymerization. So if you talk about the linkage that is formed in the product, and then that is focusing on the products. It's the same as this point that I'm putting here. Okay, some of you might have put like, because you all have seen this before, empirical formula is the same for addition polymerization, but not for condensation. So, but this is talking about the product. Okay, likewise, you talk about the linkages, that's talking about the products. Okay, so that's not the best answer I'm looking at lah. I'm looking for lah. Okay, wait, I think I'm missing some words here. Am I? No? Okay, yeah, okay. Okay, I'm going on. Last question. No, not the last one. Second last. Oh my God. Okay, but next few parts are faster. Okay, so either or question, right? Okay, you may think that's okay, last question may be more difficult, but sometimes these last few questions are easier. Okay, this either or question. As long as you know your stuff lah. Okay, some things must memorize and all. So this one here, okay, you see, I want to extract silicon using carbon. Okay, but they say that when aluminum is inside, sorry, aluminum oxide is inside. So when we do this reduction process, aluminum still remains inside after the process. That means what? That means that the carbon could not reduce aluminum oxide. And that one we already know lah, because carbon is below aluminum in the reactivity series, right? Okay, so we talk about their reactivity. You can say it's between aluminum and silicon, or you can just simply say which one is more reactive, which one is less reactive. Okay, either one. Then the second part here, explain. Why do you arrange them in this order of reactivity? That's because carbon could extract silicon. It could reduce silicon dioxide to form silicon. That shows that it's more reactive. But carbon cannot reduce aluminum oxide. Okay? So it's not as reactive. Yeah? Now, part B is on chemical bonding. And I can tell you this question, if you know your stuff, you get all the free marks here. Okay, go and memorize your bonding structure. This really give away. But you have to plan your answer, okay? Don't make it in a mess. Don't write everything. Don't just write the moment you think about it. You have to plan how you want to write it. There's so many things to talk about. Because the question is so broad. Difference in properties. And we have three substances and we have so many properties. Okay, this one generally you just group them together. Okay, this one you group it together. Electrical conductivity, you group it together. So three things. Okay? Yeah. Then other things to look at, how can you have more grouping? Okay, I scroll a little bit. Here, there is. Okay, so how can you still further group this up in your answer? So when you talk about silicon dioxide and aluminum oxide, all these are separate structures, which I have put here. So I cannot really split them. But what about density? How do you explain density? Density, you talk about the physical states. Okay, talk about the physical state. If it's a solid, then high density. Because there's no way, we don't really learn a way to distinguish, oh, which one, this one higher. So why is that this one higher? We don't learn that. Okay, but we can do a general classification. So these two are high. These two are high. This is low. So why is that so? Okay, so carbon monoxide is a gas, low density. These two are solid, high density. You can talk about the particles. Okay, in the liquid and in the solid and gas. Okay, electrical conductivity pretty short. Just talk about whether there are free moving ions or electrons or none. Okay, so these are the answers for your eyes. This is just on melting and boiling point. Okay, remember, you must always structure your answer in this way. Tell me the structure. Simple molecular structure. Giant molecular structure. Giant ionic lattice structure. Tell me the structure. How much energy is needed to overcome what bond or what attractive forces? Always these three things. Okay? Let me just show this to you. Just bear with me for another maybe 5 minutes. Just show this to you. No, you can see or not. Let me just switch the screen. So you can come up with something like this yourself if you want to. You can just take a screenshot here if you want to also. Alright, so you have the structure. First thing, tell me the attractive forces, the bond, then how much energy you need to overcome it. That's it. This is the standard one for melting and boiling points. Okay, just take a quick screenshot here for your reference for your exam. You just need it for the next 1 month. That's it. Okay, now I'm going to close this. Go back to my screen. Oops, wrong screen. Okay, so this one is on melting and boiling point. I show you the one on density and electrical conductivity. So for electrical conductivity, pretty straightforward. Okay, the main things you want to talk about is whether they are free moving ions or electrons. Okay, so only only aluminum oxide that is molten can conduct. Okay, the rest no. When it cannot conduct, right, just say no free moving ions or electrons. Okay, that's it. Density wise, okay, talk about the particles in the solid, closely packed. Okay, compared to the gas one, so more closely packed. Now this is the one you focus on. More particles per unit volume. That's why it is denser. Okay, there are more particles per unit volume because they are more closely packed. All right, that's why it's denser. So this is linked to particulate nature of matter lah, different topics. Okay, but yeah, you can still explain it based on your own knowledge. Okay. Okay, let me move on now. Take a screenshot. Now this one, a funny question. Okay, we have some percentages here, right? So we have percentage by mass of silicon inside alloy X. So that is less than 16. And then percentage of mass of elements other than silicon and aluminium, meaning the rest. Okay? So just an example. Okay, you look at this pie chart here. So we have silicon with aluminum and the rest, not aluminum, not silicon. Okay, so which means that percentage by mass of silicon and other elements for X is less than 23. So you just add up each of these, all right? And you're trying to find, okay, which one is the actual alloy that contains 2.8 moles of aluminum. Usually the question is very straightforward one. Just need to do a simple calculation. Okay? We want to find percentage by mass. We have the mole of aluminum. Let's just convert this to the mass. Multiplied by the AR, which is 27. Okay? So then from this, I want to find out all these values at the left side. So I use 100, that's what we have, minus 75.6. I have 24.4. So this 24.4 out of 100 is how many percent? So that's 24.4%. And that just nicely fall in the second one, 24 to 27. So that's Y. And that's it, 3 marks. Okay, not difficult. But you must give explanation, you must give clear working lah. Okay? So just say 24.4% is within this percentage range of alloy Y. That's it. Okay, so this is a simple question. So I'll just leave it for another 5 seconds. Okay, let's move on. Okay, last question. Now, okay, I will not read the top part, so that I'll leave it to you guys. So this question is a bit more on experiment. Okay, so we have four experiment setups. They ask you which experiment is used as a reference. And I'm sure you all are familiar with like control setup. You learned it since primary school. So control setup is the one used as reference. You're comparing with the control. You use the experimental setup to compare with the control setup. Okay, so if I just look at each of these, if I compare experiment 1, experiment 2, everything else kept the same except concentration of iodide. If I compare 2 and 3, only temperature is different. 2 and 4, only the catalyst is different. So control setup 2 must be the control. Okay, so this is one way you can phrase it. Another way to phrase it is we talk about experiment 2 being used to compare with other experiment. Okay, and there's only one changed variable, one independent variable lah. Okay, so this is putting it in a paragraph. As the most common variable where that no lah, I don't think you can phrase it that way, Aris. Be more specific a bit. Talk about what each of them has been changed. Most most num uh, most number of common variable. Most number of common variables that are unchanged. Yeah, still not very clear, but better now. Yeah. Okay, I move on. Now part B. Okay, part B is really just talking about your speed of reaction. Okay, so this whole part is really very simple. Okay, this part will just show the answer. Okay, I know it's a lot of highlights here, but essentially it's really what you need to put in for your speed of reaction answers. And this whole thing is just like chemical bonding. You know your stuff, all this is free 5 marks. Same as just now also 5 marks, right? You see this one? 5 marks. A lot to write, but all these are things that you have written a lot of times already. How concentration effects affect the rate of reaction, how temperature affect the rate of reaction, how catalysts affect the rate of reaction. You know all this, you get free 5 marks already. Okay? So just this one, just take a screenshot. But of course, you must go and practice on what you really need to write. Okay? All this. Each of these factors have their own things to write. So make sure you know what is needed. Okay? Now last question. What? Actually, this whole question, except the first question, right? The rest are like free 8 marks. Because the last question is just asking you to find limiting reactant. Okay. Okay, just finding limiting reactant. Nothing complicated. Okay? So it's just like doing half a stoichiometry question only. Alright, so this is the last question, right? This is the last question in the section B. Okay, so when you choose your either or question, right? Make sure you go through two questions, the either and the or, and find the one you are most confident in scoring the most marks. Like you see, oh, I have the 5 marks chemical bonding question, but maybe I'm not so familiar with some of the phrases. Maybe I'm better at writing answers for speed of reaction. Okay, then I do the all question, second question. So that's what you can do. You must go through the two questions, then choose the one you think that you can score the most mark. Okay? Don't just blindly choose the first one. Okay, I just tikam choose one. Okay, so I'm given the volume concentration of hydrogen peroxide. Just find the number of moles. This is a reaction between iodide and hydrogen peroxide. Hydrogen peroxide is both oxidizing and reducing agents. So it reacted with the iodide, most likely potassium iodide. Okay, so in this reaction, it's a redox. I am given 10 cm cube of iodide solution, iodide ion solution. What is my concentration? So they say for every experiment. So I just go back to the top here. Right, I have experiment 1 to 4. Experiment 1 use 0.1. 2, 3, 4 use 0.2. So I need to calculate for both. What is the number of moles used for them? So for such question, you must be very clear in your presentation. Tell me this is for experiment 1, experiment 2 to 4. A lot of students, when you all do your stoichiometry, you will skip all this presentation, which is bad because it's not clear. Okay? So I have 0.001, 0.002. Then you do your mole ratio with hydrogen peroxide. And then you do a conclusion. Okay? If you use 0.0015 moles of hydrogen peroxide, it will react with 0.003. But we don't even have that. We only have 0.001, 0.002. So therefore, iodide is the limiting reactant. Okay, you must have a conclusion. You must have this conclusion. Okay, there are fewer than this number of moles of iodide in all the experiments. This is very important. Please write it down. Okay, that is your reasoning. You see this, just finding limiting reactant is 3 marks. Yeah, very generous here. Okay, so I went through this whole paper, except the part on the blast furnace. Do you have any questions? Right, so thanks for joining me. Sherry, is there a poll or anything?
No, we will do it via the Luma. No poll, no poll.
Okay. So yeah, so if you have no further questions, thanks everyone for joining me. I hope all this has been helpful going through this whole paper. All right, and we are really very close to the exam, so please try your hardest, do your best, and try more questions. Go through all the TOS questions because sometimes they use similar concepts, repeat the MCQ or something. Okay, so please do the TOS question as well. Okay, don't too yeah, of course you can do prelim papers, but if you have the TYS, you have still some people have not done, please go and do those questions because those are the actual exam questions. Okay? Alright, if there's no further question, then that's all for today's session. I really wish all of you good luck and all the best for your O-level pure chemistry exam. Okay? Thank you. Thank you, Robertson, and yeah. Bye, Gabriel.